Many recent air conditioners use inverter control for the purpose of controlling capacity. I would like to take the time to explain the principles behind this inverter control. It is important to understand AC and DC in order to know what the inverter is. AC and DC represent types of power supplies where the former is the acronym for alternative current and latter direct current. The commonly used power supply is AC. Let's take a look at the difference between AC and DC. When running a motor on AC power, the electric current flowing into the motor reverses its direction at a regular interval. Meanwhile, when running a motor on DC power, the electric current flowing into the motor does so only in one direction. The AC power features a predetermined frequency. The frequency depends on the number of cyclic voltage alternations per second and is measured in hertz. If the number of alternations is 50 cycles per second, then the frequency is 50 hertz. If it is 60 cycles, then the frequency is 60 hertz. You may have read this phrase in catalogs. We can change the compressor speed by changing the frequency. Do you know why this is? Let's use the formula for calculating compressor motor revolutions, RPM, to understand the relationship between the compressor speed and the frequency. The compressor RPM can be obtained by the formula 120 multiplied by F over P multiplied by 1 minus S. F refers to the frequency, P the number of poles, and S the slip. The number of poles, P, is to be fixed during designing, and the slip, S, can be ignored due to fine difference, so the RPM changes according to the frequency. Let's try to calculate the RPM where the number of poles, P, is assumed as 2 and the slip, S, as 0.03. In case 1, where the frequency is 50 Hz, the number of compressor motor revolutions is calculated as 2,910 RPM. Meanwhile, in case 2, where the frequency is 60 Hz, the number of compressor motor revolutions is calculated as 3,492 RPM, resulting in a higher number of revolutions compared to 50 Hz. In terms of air conditioners, the capacity changes as the compressor motor RPM changes. As explained, the higher number of revolutions results in the higher capacity, so if the same compressor is used, the capacity becomes higher when operated at 60 Hz than when operated at 50 Hz. Next, I would like to explain the method of changing AC frequency. The frequency of AC is determined by the generator specifications. It would require a very large device if the frequency of AC sent to an air conditioner were to be changed, shrunk or extended as is. However, such a large device could not be housed in a residential air conditioner. One other method is to change the specifications of the generator from which the power is sent. This is, however, not realistic and virtually impossible. Now, how can we change the frequency of AC in a simpler manner? Actually, there is a simple method, namely an inverter system, available to change the frequency of AC. With the inverter system, AC sent to the electric circuit is temporarily converted to DC power, which is used to create AC power afterwards. Technically speaking, a circuit that converts alternating current into direct current is called a converter, whereas a circuit that converts direct current into alternating current is referred to as an inverter. And these two are collectively called an inverter system. The benefit of the inverter system is that the electric circuit can be made very small, allowing for housing within an air conditioner. It should be noted that the waveform of AC power created by the inverter system is a quasi-AC wave. Next, I would like to explain the inverter system using a circuit diagram. As you can see on the slide, the inverter system can be described with a simple diagram. The converter circuit receives AC input power and outputs it as DC power to the inverter circuit. The inverter circuit receives DC input power and outputs it as AC power to supply the motor load. The waveforms of the converter circuit input side, converter circuit output side, in other words, the inverter circuit input side and inverter circuit output side, are measured at the points indicated by the orange arrows on the circuit diagram. Next, I would like to explain the mechanism of each circuit. The converter circuit mainly uses a device called a diode. A diode allows electric current to flow through in only one direction, so it can be used when converting alternating current into direct current. To explain this mechanism using the circuit diagram, when the input side of AC is positive, the current output side remains positive. When the input side of AC is negative, the output current is reversed to be positive by this converter circuit. Therefore, the output current is always positive even if the current at the input side is alternating between positive and negative. In other words, the AC power going through the converter circuit is converted to DC at the output side. The diagram on the right shows the power waveform after the AC is input into the converter, which results in a quasi-DC wave. However, the waveform at the output side is not constant like normal DC wave patterns. Here is where a capacitor is used in the final stage of the converter circuit to provide for constant voltage. This allows for the creation of almost constant DC voltage. Next, I would like to explain how to create AC power from the DC power and how to change the frequency. In order to convert DC voltage to AC voltage, the direction of the current must be changed from one direction to two directions. Simply, a circuit like this would be necessary. If the number 2 and number 3 switches are turned on, the current flows from top to bottom in the compressor motor. If the number 1 and number 4 switches are turned on, the current flows from bottom to top in the compressor motor. Now, I would like to compare the input and output currents in the inverter circuit. The input is always DC positive. First, turning the number 2 and number 3 switches on directs the current flow from top to bottom in the compressor motor. Next, Turning the number 1 and number 4 switches on directs the current flow from bottom to top in the compressor motor. Therefore, while the input side to the switch circuit always features a one-direction flow of current, the output side of the switch circuit features a two-direction flow. Since applying current to the compressor load in two direction creates AC power, this circuit allows for the conversion of DC voltage to AC voltage. The current flows to the top when the number 2 and number 3 switches are turned on, while the current flows to the bottom when the number 1 and number 4 switches are turned on. In other words, this circuit creates quasi-AC current. If this switching occurs 100 times per second, it creates 50 Hz AC power. If the switching 100 times per second results in 50 Hz frequency, twice as much switching results in 100 Hz frequency. And if the number of switching times for 50 Hz is halved, it results in 25 Hz frequency. To put it differently, various frequencies can be created in proportion to the number of switching times per second. If the 100 Hz power is sent to a compressor motor, it results in higher capacity compared to 50 Hz. And if the 25 Hz power is sent to the compressor motor, it results in lower capacity compared to 50 Hz. By changing the number of switching times per second, the frequency can be changed in a non-step manner. In other words, the capacity of air conditioners can be adjusted linearly. This represents an overview of the inverter system, but I should add that the actual circuits are a little more complicated than this.